paper in Developmental Medicine and Child Neurology is a study on the effects of LC-PUA supplementation of infant formula on neurodevelopmental outcome at the age of 9 years. LC-PUA means long-chain polyunsaturated fatty acids. These fatty acids are better known as omega-6 and omega-3 fatty acids, say fish oil. So we aimed to investigate the effect of the addition of these fatty acids to infant formula on developmental outcome. Why did we investigate this? It is known since a long time that developmental outcome of breastfed children is somewhat better than that of formula-fed children. This difference may be attributed to many factors, including the composition of human milk. Breast milk does contain LC-PUA, and infant formula, the standard infant formula, does not contain LC-PUA. So the idea was, is it possible that the addition of LC-PUA to infant formula does improve developmental outcome? And indeed, many studies indicated that the addition of LC-PUA to infant formula has a positive effect on developmental outcome in early infancy. That is, supplementation with LC-PUA is associated with better vision and better motor outcome at the age of 3 to 4 months. However, also many studies in which infants were followed till the age of 1.5 to 2 years also indicated that this beneficial effect of LC-PUA disappears after the age of 3 to 4 months. Until now, nothing was known about the effect of LC-PUA on development at the age of 9 years. As brain development continues to change considerably during childhood, imagine, for instance, the performance of a toddler and compare it to the performance of a school-age child. It is conceivable that the effect of LC-PUA re-emerges at school age. Therefore, we embarked on a long-term longitudinal study on the effect of LC-PUA supplementation. We carried out a randomized controlled trial in which we had study infants which received during the first 2 postnatal months standard formula with LC-PUA, and the control infants the standard formula only. We also recruited a reference group of breastfed children. Previously, we reported that the development of the children at 3 and 18 months was like others also had indicated. The children who had received LC-PUA had a better developmental outcome at 3 months, but this positive effect had disappeared at the age of 18 months. This time we reassessed the children at the age of 9 years. We assessed 91 study children, 123 controls, and 127 breastfed children. We carried out a detailed cognitive assessment at the age of 9 years. In the analysis, we paid special attention to the presence of maternal smoking during pregnancy. It is well known that smoking during pregnancy is associated with a reduction in the child's IQ. In our study, a reduction of about 10 IQ points. In a previous study, we showed that this IQ reduction may be abolished by breastfeeding. And indeed, also in the present study, we found that the effect of LC-PUA supplementation largely depended on maternal smoking status during pregnancy. In children whose mother had been smoking during pregnancy, LC-PUA supplementation was associated with an improvement in cognitive function, that is, in a better verbal IQ and better learning and memory. However, in the larger group of children whose mother had not been smoking during pregnancy, in our population about 2/3 of the children, LC-PUA supplementation was associated with a small negative effect on cognition, that is, on verbal memory. In addition, in all children, that is, irrespective of maternal smoking status during pregnancy, we found that LC-PUA supplementation was associated with worse executive function. In addition, we also found, like others, that children who had been breastfed had a higher IQ than the formula-fed children. In conclusion, our study indicated that LC-PUA supplementation of infant formula is not consistently associated with a positive effect on cognitive outcome at school age. However, we also found that breastfeeding is consistently associated with a higher IQ.